Welcome back for 1.3. So in 1.1, we talked about linear equations, and in 1.2, we learned to apply linear equations with all sorts of weird examples. But we're going to extend linear equations to now quadratic equations. So linear equations are equations that are just single x's, x to the first power, things that would create lines if we drew them. But quadratic equations are equations that are now in the second power of x. So what we're going to do in this section is a ton of x squared. So let's get right into it. Ax plus b equals 0 is a linear equation, but ax squared plus bx plus c, oh, this might look familiar from when we did AC method. Ax squared plus bx plus c equals 0 is a quadratic equation. Specifically, we want to make sure that a doesn't equal 0. If a equals 0, then we would have 0x squared, and 0x squared is just 0. So that would go away, and we're left with bx plus c equals 0. But bx plus c equals 0 is just linear, right? It would just have a single power of x. So specifically when a does not equal 0, unsurprisingly. Okay, we call ax squared plus bx plus c equals 0 standard form. And in a lot of cases, we want our equations to be in standard form. There's going to be one type of equation or one type of method of solving quadratic equations where we don't need to have equals 0. But in general, we want equals 0. So, for example, x squared minus 2x equals 3 is not in standard form. But if we were to subtract 3 on both sides and get x squared minus 2x minus 3, that would be standard form. Okay, so first method we're going to have to solving quadratic equations. Linear equations, they're all kind of the same thing, maybe just some added steps as you go. But quadratic equations have all their own steps and all their own methods with their own steps each. So the method that you use entirely dependent on the problem. Some methods work for multiple problems, and there's going to be a certain method, a certain formula that we have in later on in the section that will always work. But that doesn't mean it's the only method. So the first method we're going to talk about is factoring, right? In P4, we spent a lot of time factoring, and we're going to apply that here to equations. So our steps is put your quadratic equation into standard form. So get equals 0 on one side. Get everything to one side. Once you have equals 0 on one side, factor the other side. So whatever side that you bring everything to, probably the left-hand side, factor that side. What you're then going to do is set each factor equal to 0. And you're going to solve each factor. So let's explain why. When you have something factored, right, some factor times another factor equals 0. Well, we're saying that we have two or more, two things that when you multiply them, they equal 0. Well, what's the only way that two things can multiply to 0? The only way that two things multiplied equals 0 is if at least one of those things is equal to 0, right? 2 times 4 is never going to equal 0. However, 2 times 0 will equal 0, or 4 times 0 will equal 0. So when you factor, what you're going to do is set each factor equal to 0 and solve each of those factors. And then, like I said in 1.1, check your answers. Not going to happen, not going to need to be much of a worry here in 1.3. But again, I want you guys to get into the habit of checking your answers because come 1.5, you will need to check your answers. Okay, so let's do 2x squared plus 5x equals 3. And step 1 says bring everything to one side. Get to standard form. Well, we have equals 3. If we want to bring this 3 over, all we need to do is subtract 3 on both sides. Okay, so 2x squared plus 5x minus 3. This is factorable. And we spent an entire section factoring things that looked like this. So I'm not going to go over the factoring here. If you're looking for that video, that would be section P4. I can link that into the description. But please go practice factoring before you try and understand the factoring part here. That or just take one of the methods that we do later on. So 2x squared plus 5x minus 3 factors as 2x minus 1 times x plus 3 equals 0. Okay, and here's what I mean. Notice that we have two factors that are being multiplied together, and when we multiply them, they equal 0. The only way that these two things can multiply to 0 is if at least one of those things is 0. So what we're going to do is set both of them equal to 0. If this equals 0, 0 times x plus 3 is 0. That would satisfy our equation. If x plus 3 is 0, then 2x minus 1 times 0 is also 0. That would also satisfy our equation. So set each factor equal to 0, and what you now see is these are just a pair of linear equations. Add that, very nice, easy linear equations. This, add 1 to both sides, divide by 2. Here, just subtract 3 on both sides. So what we get are 2 answers. One thing that makes quadratic equations very different from linear equations. Linear equations, in most normal cases, we got one single answer, x equals 3 or x equals negative 5. But for quadratic equations, what we're going to get a lot of the time is 2 answers. 2 answers, very normal. We will look into situations of how we know what those 2 answers are going to be, what type of answers we get. But for right now, not going to think about that. So it's very normal and it's very okay to get 2 answers for quadratic equations. If you want, go back in and check each one. Just as an example, let's just check negative 3. Well, negative 3 squared would be 9. 2 times 9 is 18. 5 times negative 3, negative 15. 18 minus 15 is 3. And the same would be true for 1/2. 3x squared equals 2x. Again, we need to get one side to be equal to 0. So let's subtract 2x on both sides. Okay, well, no number this time. And if anything, this is a lot easier to factor. We can factor out just an x. And now we have x times 3x minus 2 equals 0. These are still 2 factors being multiplied to 0. One of those factors is just plain x, and that's okay. So we're going to set x equal to 0, and we're going to set 3x minus 2 equal to 0. Well, if anything, this actually made our job quite easy. X equals 0 is already done. 3x minus 2 equals 0. Add 2 to both sides. Divide by 3. So again, we get 2 solutions. So that's quadratic equations. It's nice when they boil down to linear equations almost immediately. Just a little bit of tinkering, just a little bit of factoring makes our job a lot easier to deal with. Okay. X squared plus 16 equals 8x. Well, let's subtract 8x because we need to get 0 on one side. And this factors quite nicely to x minus 4 times x minus 4 equals 0. Okay, same thing. Set each factor equal to 0. But what you notice is that we get x equals 4 twice. Well, for now, we'll talk about what that means to get the same answer twice. But that's in chapter 3. This is chapter 1. Your final answer is just x equals 4. There's only one x that satisfies this quadratic equation. So the 2 previous examples, we have 2 x's, 2 answers, 2 solutions. And now we had only one. And that is, again, totally fine. It doesn't mean there's anything wrong with the equation. There's nothing wrong with your work. It is possible that you get only one solution. And again, at the end of the section, that's when we'll discuss how we get a certain number of solutions and what type of solutions. So we like the method of factoring a lot because factoring is easy, right? In comparison to other things we're going to talk about, factoring is very familiar to us and we know how to factor, but not always is it going to be the only option, right? We're also going to talk about this thing in just a wee tad, but in general, we need a stepping stone to that. So square root property and completing the square are going to be some of your least useful methods because you're probably always going to want to go for factoring or quadratic formula, but it is a good stepping stone to what we talk about. And when it works, it's kind of nice. So let's talk about square root property first. Square root property can be used if the factored side is a perfect square. And what I mean by that is something like x plus 2 squared. That would be a perfect factored square. So the other nice thing about square root property is that the other side doesn't need to be equal to 0. In factoring, one side has to be equal to 0 because we need to be able to set each factor equal to 0 separately. But for square root property, we're not going to need that to be the case. We're going to need equals 0 for quadratic formula, but for square root property, we do not require that. Okay, so in general, if u is some algebraic expression and d is some number greater than or equal to 0, so some expression squared equals some non-negative constant, what we can do is take the square root of both sides. Just like in linear equations, when you add 5 to both sides or divide both sides by -2, you are allowed to take the square root of both sides. However, when you do that, when you take the square root of both sides, what you need to pick up is a plus and minus. You are allowed to take the square root of both sides so long as one side gets a plus and minus. So the reason for this has to do with the square root of u squared, right? We said square root and that squared cancel each other out and would be absolute value of u. But we haven't talked about enough properties of absolute value to prove that right now. However, that does reappear toward the end of the chapter. We're just going to kind of take it for granted for right now. So if u squared equals d, you can take the square root of both sides to undo the squared, right? How do you undo plus 5? By subtracting 5. How do you undo u squared? By square root of both sides. However, when you take the square root of both sides, you need to get plus and minus. I also want to stress this is only for when we are solving equations. Think back to chapter P when we were just looking at random radical or root expressions. We don't magically pick up a plus and minus when there is no equation to solve. This is only used when we are solving an equation. When you take the square root of both sides, that is when you pick up plus and minus. Okay, so x squared minus 3 equals 0. How we would do this before via factoring is a little different. How we would factor this is say, oh, this is a squared minus b squared. Well, difference of squares, a squared minus b squared, a plus ba minus b. You set each factor equal to 0, and you get x equals positive square root of 3 and x equals negative square root of 3. But this is really uncomfortable because this isn't nice. Saying that 3 is square root of 3 squared and we have to factor it that way, that's not necessarily very helpful. So here's where square root property comes in. Instead of factoring something that isn't as naturally factorable as other things we've talked about, why don't we instead add 3 to both sides? And now our expression side is a perfect square. It is literally something squared. When we have something squared, we can undo squared with the square root. Again, however, when you take the square root of both sides, you need to pick up a plus and minus. So square root of x squared, well, that undoes the x, but on the other side, you need to get plus and minus the other side. That is really, really, really important. So a little bit quicker a little bit more, a little easier to picture. Okay, let's do another example where it's not just x squared, right? X squared minus 4 equals 0. You can kind of see like, oh, 2 and negative 2. But what if we have something like x minus 7 whole thing squared? Again, this is a great example of something squared, and that would be our giveaway to take the square root of both sides. But again, when you take the square root of both sides, you need to pick up a plus and minus. Okay, square root and the squared cancel each other out. That's the whole point. Square root of 9 is 3. So we get x minus 7 equals plus and minus 3. Now, this is a really good step, and if you can get here, you did the hard work. However, our answer should be x equals one single thing. So we now need to do x minus 7 equals positive 3, and x minus 7 equals negative 3. And again, you're starting to see the pattern for quadratics where we're always going to get two answers. Let's add 7 to both sides. For each problem, add 7 to 3, we get 10. Add 7 to negative 3, we get 4. So we again get two answers. And that's square root property. One more example. X minus 3 squared equals 5. Again, this is a perfect square. So let's take the square root of both sides. And again, when we take the square root of both sides, we get plus and minus on the other side. Square root and squared cancel each other out. So we get x minus 3 equals plus or minus square root of 5. This is not nearly as pretty. So why don't we just add 3 to both sides? Now you might be wondering, why don't we do it separately? X minus 3 equals positive square root of 5. X minus 3 equals negative square root of 5. It worked nicely in the last question because the answers were very easy to simplify. But in the case of square root of 5, not really. You could say your answers are 3 plus square root of 5 and separately, comma, 3 minus square root of 5. But this answer is nice and simplified as well. Or not nice and simplified. It's a nice simpler way of writing that. Also, you'll note that I don't use decimals in a lot of situations because in general, decimals aren't necessarily always exact. For example, if you plugged in 3 plus square root of 5 into your calculator, you would get a really ugly irrational number that at some point you need to round. So instead of doing the extra step of plugging this into your calculator and rounding, why don't we just say the answer is 3 plus square root of 5 and 3 minus square root of 5. So for those of you that are taking my class, I love this answer right here. You give that to me, we're all for it. But from course to course, you might be told to do decimals, or you might be told to write your answer separately, whatever works. So if it can be simplified like the previous question, simplify it. If not, it's okay. Let's do one more example. 9x minus 5 squared minus 49. Well, the left-hand side, as it's written, is not a perfect square, right? 9x minus 5 is a perfect square, but minus 49 doesn't make this factor as nicely. So what's the remedy? Why don't we just add 49 to both sides? Well, now this is a perfect square. We can take the square root of both sides, make sure we add our plus and minus to the other side. Square root and squared cancel each other out. Square root of 49 is 7. So now we have 9x minus 5 equals positive 7. 9x minus 5 equals negative 7. This is just a pair of linear equations, and we get two answers. I haven't made it clear before, but also we like to write our answers in numerical order. So for example, negative 2/9 is before 4/3 on a number line. So writing x equals negative 2/9, comma 4/3 is a really nice way of summarizing your answer. You could, in theory, just leave your answer as x equals 4/3 and x equals negative 2/9, but we like to simplify things. Okay. If our quadratic is not a perfect square, what we can do is make it a perfect square, and that's called completing the square. This is a weird method for solving equations. I don't think many of you will use it all that frequently, but it is technically needed to broach the topic of quadratic formula. So let's do that. This can only be done if a equals 1. So ax squared plus bx plus c equals 0. We need to make sure that a equals 1. Because if a doesn't equal 1, it's a little bit easier to, a little bit more difficult to try and picture. So just be careful for that. Steps to do this: move your constant term away from your variable terms. So you have an x squared term, you have an x term, and you have some constant. Move your constant to the other side. Okay, the part that makes completing the square is that we're going to add b over 2 squared to both sides. Now, that seems like kind of a silly step. However, when you add b over 2 squared to both sides, what that allows you to do on your variable side is factor to just x plus b over 2 squared. And the right side, well, we move the constant to the right side. We added another constant to the right side, so the right side is just a constant. Well, we now have a perfect square. We now have a constant. It's just square root property from there. Okay, so let's do an example of this. Step 1, let's get our constant out of the way. So plus 8, let's bring plus 8 to the other side by subtracting 8 on both sides. Okay, this is ax squared plus bx plus c. And what we want to do is add b over 2 squared to both sides. So if this is ax squared plus bx plus c, what is b? B is 10. Okay, so we're going to add b over 2 squared, 10 over 2 squared to both sides. Well, 10 over 2 squared, but we're not adding it to just one side, we're adding it to both sides. If we add it to both sides, we don't change anything. Okay, well, we can simplify this. 10 over 2 is 5. 5 squared is 25. Negative 8 plus 25 is positive 17. And also, this factors very nicely. We went from something that could not be factored as it was written to something that could be factored with just a constant on the other side instead of 0. So x squared plus 10x plus 25 is x plus 5 squared. Negative 8 plus 25 is 17. And now from here, square root property, pick up a plus and minus, and just subtract 5 on both sides. And you can leave your answer like that. That's completing the square. So it's kind of a weird method, kind of like a why are we doing this type of method? There are other ways. And honestly, you probably won't go for completing the square in most cases. And that's okay. There's a reason why we have a whole bunch of different methods to solving these things. So even if you don't use completing the square, that's fine. The other methods work just as nicely. 3x squared minus 6x minus 15 equals 0. Let's complete the square on this. However, we can only complete the square when a is 1. Well, ax squared, a is now 3. So just like that, we can't do completing the square, right? Just move on? No. What we can do is simply divide everything by 3, divide both sides by 3. Well, when we do that, 3x squared divided by 3 is just x squared. Negative 6x divided by 3, negative 2x, minus 15 divided by 3, negative 5. And it's nice because 0 divided by 3 is just 0. So this equation simplifies a little bit more nicely to x squared minus 2x minus 5 equals 0. Okay, now let's complete the square. Let's get our constant term away. Let's add 5 to both sides. Now we want to add b over 2 squared to both sides. B is always the number attached to x. So b is negative 2. We're going to add b over 2 squared to both sides, negative 2 over 2 squared to both sides. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Left side factors to x minus 1 squared. Right side simplifies to 6. And now square root property, take the square root of both sides, get plus and minus, x minus 1 equals plus or minus square root of 6, and add 1 to both sides. Okay, so completing the square, like I said, probably not something you do all that frequently, but quadratic formula is something you will definitely use at some point. So we need completing the square to derive the formula for quadratic formula. So I'm going to do it in the presentation. It's a little complicated. So if it scares you a little bit, don't worry too much. In general, you will never be asked to derive the quadratic formula, but I will still show it. If it freaks you out, skip along just a little bit. So in general, quadratic formula is the most powerful way to solve quadratic equations. I say that because it always works. It might be more work than necessary, but it always works. So if you're really struggling to try and factor, you're really struggling to try and use like square root property or completing the square, you can go right for quadratic formula, assuming that we're in the correct state for it. But yeah, it always works. It might be too much, but it's better to do too much than not enough. So to do this, the right side must be equal to 0. So factoring method, one side has to be equal to 0. Quadratic formula must be equal to 0 on one side, but completing the square root property, that is not the case. But okay, it's a little complicated to derive, like I said, but the quadratic formula is right here. For ax squared plus bx plus c equals 0, the solutions to ax squared plus bx plus c equals 0 is right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c all come from ax squared plus bx plus c. So if you know what a, b, and c are, you can go right for plugging in a, b, and c, and that's how quadratic formula works. I understand it's a very scary looking formula, but don't worry, it functions just like any other thing that you're plugging stuff into. Okay, so I am going to derive it for the presentation, for the sake of the presentation. However, if it's kind of scaring you or you're not really following along, don't worry, I'm just doing it for completeness. Skip ahead like, I don't know, 30 seconds to the first example, to skip over this part. But if you're sticking around, let's do it together. So we're going to complete the square. So let's bring positive c to the other side. So let's subtract c on both sides. And now we want to divide everything by a because we know we can only do completing the square when a is equal to 1. So we divide everything by a cancels out, b over a, and c over a. Okay, well now we want to complete the square. So we're going to add b, in this case, b over a divided by 2 squared to both sides. Okay, well, b over a divided by 2 is b over 2a. And we're going to add that to both sides. Yeah, it's already pretty messy. Now, left side is very nice. That factors to just x plus b over 2a squared. And now here, let's rearrange terms. Let's put b squared over 4a squared minus c over a. So I distributed the 2. I squared everything. B squared, 2 squared is 4. A squared is a squared. And just rearrange terms so that the minus would be to the right. Okay, well, what we can do is now combine these two terms by getting a least common denominator. So we need to multiply c over a by 4a so that we get a times 4a squared. Okay, well, now they have the same denominator, so we can subtract them. Oh, b squared minus 4ac. That looks familiar. Well, now square root property says take the square root of both sides. When we do that, the square root cancels out, x plus b over 2a. This was a little bit of a mistake. This square root should still extend over everything. That's a small mistake. It should be square root of 4a squared at the bottom here. Okay, yeah. But now we can subtract b over 2a on both sides. Again, square root of 4a squared, it was still supposed to be square root here. Square root of 4a squared is 2a. Okay, well now they have the same denominator, so we can add or subtract them. That was a very messy derivation. I promise it looks better in person, but yeah, if you wanted to know where it came from, there you go. So with that said, let's get right into examples. 3x squared equals 5x plus 2. So again, for us to do quadratic formula, we need everything to be on one side. So let's subtract 5x and let's subtract 2 on both sides. So one thing I should note is that you should always try and factor. If you're very good at factoring, if you're very comfortable factoring, you should try and factor first, because quadratic formula has a lot of space for you to make a mistake. So I believe this factors. Yes, this factors. You would get two very nice rational answers. So in the event that you can factor, you should. But again, quadratic formula will always work, even if your answers are a little ugly. So for us to do quadratic formula, we need a, b, and c. Well, a, x squared plus bx plus c. So a is 3, b is -5, and c is -2. I'll do that again. Ax squared plus bx plus c. Ax squared, a is 3, plus bx, b is -5, plus c, c is -2. And now what we're going to do is take a, b, and c and plug them in for a, b, and c. So we get that, right? Wherever we see a, write 3. Wherever we see b, write -5. Wherever we see c, write -2. Nobody said it was pretty, but at least now it's just calculation. Okay, -5 is +5. -5 squared is +25. -4 times 3 times -2, +24. 2 times 3 is 6. 25 plus 24 is 49. The square root of 49 is 7. So we get 5 plus 7 over 6, 5 minus 7 over 6. Well, it's a linear calculation, but not a very scary one. So our answers are -1/3 and 2. It seems very anticlimactic that quadratic formula ends up being just a calculation, but that's really all it is. There's some progression to get up to quadratic formula. If I just showed you quadratic formula, it wouldn't be very exciting, but at least now you understand where it comes from. Okay, let's do another one. 6x squared minus x minus 2. I think this is another one that could factor, but again, let's practice doing quadratic formula. Okay, well, this is already ax squared plus bx plus c. Again, ax squared plus bx plus c. Ax squared, a is 6, plus bx, b is -1, plus c, c is -2. So there's quadratic formula. Plug in a, b, and c and use parentheses so that you don't screw yourself up. Okay, -1 is +1, -1 squared is +1, -4 times 6 times -2 is +48. 2 times 6 is 12. 1 plus 48 is 49. Square root of 49 is 7. And again, 1 plus 7 over 12, 1 minus 7 over 12, we get 2 answers. So kind of not a mistake, but a coincidence that we have square root of 49 twice. That doesn't normally happen for every example. It just happens to work out for this one. Okay, and let's do another one. 5x squared plus 12x plus 4. So if this is ax squared plus bx plus c, a would be 5, b would be 12, and c would be 4. Alrighty, again, just plugging everything in. 12 squared is 144. 4 times 5 times 4 is 80. 144 minus 80 is 64. Square root of 64 is 8. -12 plus or minus 8 becomes negative 12 plus 8 over 10, and negative 12 minus 8 over 10. And we again get two solutions. So you think that quadratic formula is this big, very ugly, very forgettable thing, but it's actually not that bad. If you know what A, B, and C are, if you plug them in correctly, it just becomes easy multiplication, subtraction, square roots. So don't be so scared of it. I understand it's daunting. It looks very scary, but it really is just a plug and chug. Okay, x squared minus 7x plus 7, ax squared plus bx plus 7. A would be 1, B is negative 7, and C is positive 7. So plug it in. Negative 7 squared is 49. 4 times 1 times 7 is 28. Well, negative 7 is positive 7, but 49 minus 28 is just 21. And square root of 21 is not a pretty number. So going back to those square root property examples where I just said, leave it the way it is, don't worry too much about it. There you go. There's a perfect example of how this would look in quadratic formula. So instead of trying to figure out what square root of 21 is, instead of getting decimals, this answer, very nice and pretty. However, some instructors, if you're watching, you might prefer to have 7 plus square root of 21 over 2, comma 7 minus square root of 21 over 2. So this is a nice condensed form to say both solutions, but it would be a little bit more correct to write them out separately. However, less writing, the better. 2x squared plus 12x minus 18. You could do quadratic formula on this. However, what you might see is that all of these numbers are divisible by 2. So instead of dealing with A is 2, B is 12, and C is negative 18, why not just divide everything by 2? Well, when you divide everything by 2, you get x squared plus 6x minus 9. A, B, and C are not as big, and they will save you some time in simplifying. Again, you would get the exact same answer using 2, 12, and negative 18. It just might be a less simplified version. Okay, so again, plug it in. A is 1, B is 6, C is negative 9. 6 squared is 36. Negative 4 times 1 times negative 9 is positive 36. 36 plus 36 is 72, but square root of 72 is 6 square root of 2. So even though you don't get a perfect square on the inside, doesn't mean it's not simplifiable. I think that's a word. So square root of 72 is 6 square root of 2. Just because square root of 21 in the previous question was not able to be simplified, that doesn't mean all plain square roots can't be simplified. Okay, last but not least from here, let's just divide both of these by 2. Negative 6 divided by 2 is negative 3. 6 divided by 2 is positive 3. So this would be a nice, pretty final answer. If you got to this point, this is most of the work. You did most of the work right, but we're able to simplify just a little bit more. X squared minus 6x plus 9 equals 0. A is 1, B is negative 6, and C is 9. Okay, plug it in. Negative 6 squared is positive 36. Negative 4 times 1 times 9 is negative 36. Alrighty, 36 minus 36 is 0. And square root of 0 is just 0. Well, if you did 6 plus 0 divided by 2 and 6 minus 0 divided by 2, you would get 3 both times. So again, we've seen plenty of times that quadratic equations can give one solution or two solutions. Just because you get one type of solution over another doesn't necessarily mean you did anything wrong. However, just wanted to show you that we could have done this easier. You might have noticed it right away, but you could have also been very much in the quadratic formula groove. This can be factored as x minus 3, and you could get x equals 3 that way. So again, I just wanted to illustrate the fact that just because quadratic formula works every single time, it doesn't mean it is the easiest method. So just keep an eye out for when you want to use which method and try and use the best method for all of these problems. Well, what you noticed a couple times is that we got things like two solutions, two rational solutions, or we got one solution like the last problem, or like that square root of 21 question where we had two solutions, but we knew square root of 21 was irrational, so we would end up being irrational anyway. So with that said, how do we know, how can we get foresight as to what type of answer we can get? Well, that's where discriminants come in. So the discriminant is the b squared minus 4ac in the quadratic formula. So we had negative b plus or minus square root of b squared minus 4ac over 2a. That b squared minus 4ac inside the square root is called the discriminant. Now, the discriminant is very useful because depending on the value of the discriminant, the quadratic formula produces different types of answers, different types of solutions. So if you know what the discriminant is, you can figure out which type of solutions you would get. Okay, if the discriminant is a perfect square, like those first two examples where the discriminant was 49, if it's a perfect square, there are two real rational solutions. Go back to those first two examples when we had square root of 49 and see that we had two very nice, very pretty fraction answers. They're real numbers and they're rational solutions. If the discriminant is positive, but not a perfect square, like 21, there are still two solutions because we still had plus and minus square root of 21, but instead of being rational solutions, they're irrational solutions. So perfect square, two real rational, positive but not a perfect square, two real irrational. If the discriminant is 0, well, that was like that very last example we did where we only got x equals 3. So if the discriminant is 0, square root of 0 is 0, plus and minus 0 just goes away. You get one real rational solution. Last but not least, it didn't happen this time, but if the discriminant is negative, then you would get square root of some negative number, and there are two complex solutions. Now, we've spoken very, very little about complex numbers. I mentioned it all the way in P1. We kind of looked at it a little bit in P6 with square roots and saying, well, square root of a negative number doesn't exist. So in that case, we say there are two complex solutions, and it's almost like the entire next section is about complex solutions. So before we get into something like that, let's just do some very quick discriminant examples. 2x squared minus 3x minus 7. A is 2, B is negative 3, C is negative 7. Again, don't worry about solving it. Let's just determine what kind of solutions we would get without going through all the work. B squared minus 4ac, plug in A, B, and C, we get 9 plus 56, 9 minus negative 56, 9 plus 56 would be 65. 65 is positive, but not a perfect square, so we get two irrational solutions, two real irrational solutions, but we don't really know the difference between real and complex at this moment right now. Next section we will. X squared plus 6x plus 9. A is 1, B is 6, C is 9. So plug that all into the discriminant. 6 squared is 36. 4 times 1 times 9 is 36. 36 minus 36 is 0. We got 0. That is one rational solution. X squared plus 2x plus 3 equals 0. All right, A is 1, B is 2, C is 3. Plug it in. 2 squared is 4. 4 times 1 times 3 is 12. 4 minus 12 is negative 8. That's negative. Two complex solutions, and we will talk about two complex solutions in 1.4. So I will see you there. Bye.
Hi everyone, thank you so much for watching. I hope this lecture helped and that you learned something. Just wanted to give the brief disclaimer that this lecture for this section is based on and adapted from the section in College Algebra and Trigonometry, the 4th edition by J.S. Ratty, Marcus McWaters, and Leswowska Zerpek. So just wanted to give that disclaimer. I'm not affiliated with any of the authors. I'm not affiliated with Pearson, the publisher. This is entirely a presentation and lecture I created based on the book. So thank you so much for watching, and see you in the next section.